Well, hello and welcome to another Learning Together session sponsored by the Rusea's Brosis Foundation. We have had quite a few sessions before, and we plan to have more sessions going forward. Recently, we covered how to graph circles that have centers at the origin, as well as circles that have centers elsewhere in the coordinate plane. We realized that the formula, if the center is at the origin, was something like this. And that's assuming that the circle has a center at the origin. And R is the radius of the circle. And then we also discovered that if the center was not at the if the center was not at the origin, that is 0, 0, the point 0, 0, then it will be x minus where HK, point HK is the actual center. So these two equations or these two templates have to do with the equation of circles. This, the origin is at 0, 0. And this, the origin is elsewhere. So if you put 0, 0 here, it will come right back to the original that we have here. Okay? Today, we're going to look at another type of graph, not the circle, but something else. So we have dealt with lines, equation of line y equal to mx plus b, and also y minus y1 equal to m times x minus x1, and also ax plus by equal to c. The three formulas used, or the three equations used for the equation of a line. We have dealt with circles, and today and tomorrow and next session, or maybe 3 sessions, we might end up spending with parabolas. So the question is, what do parabolas look like? In order to answer that, I'm going to let us do some exploration. Let us do some exploration. If I ask you to draw the graph of y equal to x squared, very simple. Y equal to x squared. Look at it. Whatever x is, y is the square of it. So if x was -2, y would be equal to 4. If x was +2, y would be equal to 4 also. So there seems to be, whenever there's a negative value for x, its corresponding positive value has the same value for y. So therefore, it seems that there is some symmetry. That is, there's some duplication of y values. Okay? Well, let's see how we could graph this. Okay. One way to graph it is to get a set of points. And then plotting the points, we should be able to see a pattern. And then we just connect the points. So let's try that and see what happens. So let's go with x values and y values. So if x is, say, -3, then y will be 9. If x was -2, y would be 4. If x was -1, y would be 1. If x was 0, y would be 0. If x was 1, y would be 1. If x was 2, y would be 4. What have I done? I've just taken integer values of x from -3 up to +3. And I notice that there's a pattern. The y values are duplicated. So let's go to the graph. So what I plan to do is, just so you know, I plan to explore. Notice the word analyze. We're going to explore this thing so it starts to make sense. I've been accused of going very fast sometimes. And that is true. But for the next couple sessions, I'm going to slow it down a little so you can follow me, or you can digest this as I go. So notice this is 1 point, 0, 0. And if we use these points, 1, of course, you could extend it, but for now, let me raise this up a little bit. There you go. Okay, so 0, 0 is right here. -1, so we're going to go all the way up to 9. This is 3, 6. Okay, so -1 is 1. +1 is 1. -2 is 4. -2 is 4. +2 is 4. And then -3 is 9. +3 is 9. So we can see that there is a symmetry. It's duplicated across the y-axis. What is on the left is also on the right. And your graph would look something like that. Okay? And that's the shape, almost like a U. Okay? Okay, so a couple things to note here. This part, which is right here at 0, 0, has a name. It's called the vertex. This is called the vertex. V-E-R-T-E-X. That's the vertex of your parabola. Oh, the shape is called a parabola. So y=x², this is with a standard form. This would be like your foundational. This is your basic. Okay, this is your basic parabola. So this is a vertex, and this line right here in the middle is like a mirror line, has a name. It's called the axis of symmetry. Yes, every parabola will have a mirror, will have a central line that runs straight smack through the middle. Interestingly enough, when you look for the vertex, in this case, the vertex is at 0, 0. That's what the vertex is. 0, 0, that's called a turning point. In this case, it is the actual minimum value for the graph. The graph goes up from this point. That's the lowest value for the graph. It goes up from there. You will find an inverted parabola where this portion is up here and then it opens downwards. We'll discuss that later. But for now, just wanted to give you some ideas. But just observe, what we have discovered is that the graph of y=x² opens upward. So it has a minimum and it opens upwards. It is symmetrical. The central line that goes through the mirror line is called the axis of symmetry, and the turning point is called the vertex. Okay? Now, oh, by the way, there is a very, very useful application that is very good at graphing. If you just go on the internet and if you just go and look for what is called Desmos. Desmos. It has nothing to do with my name, Desmond. So Desmos, D-E-S-M-O-S. It is free for teachers. It's also free for students. You could use that to graph anything whatsoever. And it is extremely useful. Just go on the internet and type in Desmos. And you'll see the software. You'll see the easy application. And you can just use it. Free of cost. Okay, keep that in mind. But don't depend on Desmos. Understand how the graph is done. And then if you want to get a quick graph, you can use Desmos to get your answer. So what would I like to do now? I would like to see what happens to our graph as we change the equation, as we modify the equation. How is the graph affected? As we modify this, how does the graph get affected? Well, let's see. So this is the axis of symmetry. We'll remove this now so we can have some space. What happens if, instead of y equal to x squared, we had y equal to x squared plus 2? What would happen to the graph? So instead of y equal, oops, not y squared. Instead of y equal to x squared, we had y equal to x squared plus 2. How will that affect the graph? How will it shift the graph? Would it shift or would it stay the same? Very good question. Well, let's go back. According to this chart we have here, the first set of value here is when we have just x squared. What happens if we use x squared plus 2? Then this would not be 9, this would be 11. This would not be 4, this would be 6. This would not be 1, this would be 3. This would not be 0, this would be 2. This would not be 1, this would be 3. This would be 6. This would be 11. So all the y values went up by 2. So the first one, this is going to go from here, 0, 2. This is going to go from here to 3. Similarly, this is going to go to 3. And then this is not going to go, 2 is going to go to 6. So this is going to go up to 6. 2 is going to go up to 6. So what we discover is that our graph is going to be raised up. It's going to be shifted vertically up 2 units. So adding 2 causes the graph to be raised upwards 2 units. Every point goes upward 2 units. And that's what is called a transformation. Our graph is transformed, a word for change. It is transformed. And there are different types of transformations. You have what is called a slide, which means that it's just shifted, moved to the left, to the right, up or down. That's a transposition. Or rather, it's a translation, You could have a reflection where the graph is reflected, or it could be a rotation where it is spun around, or it could be an enlargement where it is increased, or it could be a reduction where it is minimized. So there are different types of transformations, different types of ways of changing your basic or default graph, your starting point, okay? But for this one, if we add a number, it causes the graph to go up 2. If we were to subtract a number 2, it's going to pull the graph down from the original spot down 2 units. So what, again, we're analyzing the graph of the parabola. So once we add something to the quadratic term, it causes the graph to shift, whether up or down. If it is positive, it goes up. If it's a negative number, it goes down. It pulls it down. Okay? So that takes care of that for now. Let's see something else. What happens if we made we made something else? Suppose we had y equal to, in this case, we're going to put y equal to x plus 2 squared. So whatever the x value was, we're going to cause it. We're going to add 2 to it and then square it. So we're going to add 2 first and then square it. So what happens? So here we go. We're going to compare this with the original. So in this case, it's going to be x plus 2 squared. What happens? When x is 0, okay? When x is 0, y is going to be 0 plus 2, y is going to be 4. When x is negative 1, y is going to be negative 1 plus 2 is 1 squared is 1. When x is negative 2, y is going to be negative 2 plus 2 is 0. So y is going to be 0. When x is negative 3 plus 2 is negative 1. Negative 1 squared is 1. Let's try one more time. When x is 0, y is going to be 0 plus 2 squared is 4. When x is negative 1, y is going to be 1 squared is 1. When x is negative 2, y is going to be negative 2 plus 2 squared is 0. When x is negative 3, y is going to be negative 3 plus 1, negative 1. It's going to be negative 1 squared gives you 1. What happens when y is 1? 1 plus 2 is 3. 3 squared is 9. When x is 2, 2 plus 2 is 4. 4 squared is 16. And then what happens to the next one? At negative 4 plus 2 gives me negative 2 squared gives me positive 4. So now you see that the numbers shift. You see we had 4, 1, 0, 1, 4, 9. Now we have 4, 1, 0, 1, 4. Then we're going to have the 9. So there's a shift. So let's plot those points and see what happens. 0 is going to be mapped onto 4. Negative 1 is going to be mapped onto 1. Negative 1 is going to be mapped onto 1. So it's going to be right here. Okay, good. Then negative 2 is going to be mapped onto 4. Negative 2 is going to map onto 4. Sorry, negative 2 is going to map onto 0. Negative 3 is going to map onto 1. Negative 3 is going to map onto 1. Negative 4 is going to map onto 4. So what is happening here? According to this, the graph is now going to go like this. So by putting a positive 2 inside the parentheses, it's caused our vertex to go 2 to the left. So every point shifts to the left. This point here goes 2. This point here goes 2. This point here goes, so all the points shift 2 units to the left. So notice, you adding 2 causes our graph to shift 2 to the left. So what happens if we subtract 2? what is going to happen to our graph? Well, guess what? If you put -2 here, instead, your graph is going to go this way, to the right. So you'll end up with something more like that. Okay, so let's go over this. I'm going to erase the board because it's starting to look very confusing. And then we'll summarize what we just covered. So the first one is called the parent function. That is y equal to x squared. And the graph of that is very simple. Gives us a nice curve like that. Okay, so that's one. Two, if we have the parent function plus a, just add a to it, it means that it's going to cause your graph to go up a unit. Everything goes up. Everything shifts upward from the vertex, from the 0, 0. This is 0. 3, if we have y equal to x squared minus b, then that's going to cause our graph to go down. So a plus causes the graph to shift up. A minus causes the graph to go down. Then the next thing we have is 4. If we have y equal to x minus a squared. Let's do plus first. Let's do plus. Then that causes our graph to shift a units to the left. So this is the original graph. And this is a. So the graph is going to be this way. And finally, if we have y equal to x minus b, so the plus causes us to go to the left, the minus causes us to go to the right. So that's a contradiction. So we have to be very careful, otherwise we'll get tricked. Okay, so this will take us to b. Okay, so that takes care of that. So now what we'd like to do is, we'd like to be able to draw a graph of a parabola, a random parabola that's given. Not something as simple as this, but something that is a little bit more involved. How do we go about doing that? So let's look at that now. So by now, I'm sure you realize that when we talk about parabolas, we're talking about graphing a quadratic equation. Remember, quadratic means that the highest exponent is 2. Okay, so it's a quadratic equation. So let's look at this. The general quadratic equation is y equal to ax squared plus bx plus c. That's the general quadratic equation. Y equal to ax squared plus bx plus c. Okay? And we need to be in a position that once we're given any quadratic equation like that, we should be able to graph it. What are some of the things that we should look for as we prepare to graph it? What are some of the key things that we should identify? as we approach graphing. 1, find the vertex. That's the first thing you should do. We'll discuss how to find it. Okay? 2, find the x-intercepts. If they exist. 3, find the y-intercept. Okay. If it's a reasonable number, sometimes the y-intercept could be a large number, so it would not be physically useful if we're trying to sketch a graph. But if the y-intercept is a decent small number, then it will be a very useful way to go. Okay? And next thing is have about 3 points on so again, find the vertex, we'll discuss that. Find the x-intercepts if they exist, we'll discuss that. Find the y-intercept if it is reasonable, we'll discuss that. And then we should aim to have about 3 points on the left of your axis of symmetry, 3 points on the right. And then we just connect. Okay, can you tell me how I end up with 7 points? It says 3 points on either side of the axis of symmetry, but yet I'm saying connect the 7 points. The reason that there are 7 of them is that the vertex is by itself. So the vertex is on the axis of symmetry. So you want 3, 3. 3 on the right, 3 on the left, vertex smack in the middle. Okay? So that is our goal. And now we're going to go about trying to do one of those questions together. So we're going to write an equation on the board, and then we're going to slowly go through the process of trying to sketch the graph. Okay. What I'm going to do is, instead of just writing a random equation out of my head, I'm going to use an example so that we end up with something that's reasonable. Here we go. Okay, I need my glasses. Let me just take this time to define the axis of symmetry. Okay? The x value at the vertex is equal to minus b over 2a. So when you look at that graph, whatever minus b over 2a is, will give you the x value of the vertex. Okay? Now, the y value at the vertex it's really whatever this is, plug it into the equation. It's going to be basically f of minus b over 2a. In other words, whatever this number is for x, plug it into the equation that you're given, and that will give you the y value. Okay? And then the axis of symmetry is x equal to minus b over 2a. So whatever number is here for the x, whatever number we get for the x value, that is also the equation of the axis of symmetry. It's a vertical line, right? We're passing through the point where x, passing through the x value at the vertex. Okay? So now that we have these three things here, let's go ahead and start working on an example. The example I'll use that will give me a good start will be the graph y equal to x squared minus 4x plus 3. X squared minus 4x plus 3. Okay. Writing y equal to x squared minus 4x plus 3, you could also write it as f of x equal to x squared minus 4x plus 3. This is called the standard, this is called the function notation, function. F of x equal to, it's the same thing. All I've done is replace the y by the function notation, but it's the same thing. It means the same thing. F of x is just the same as y. But with this format, then it makes it easier for you to find the vertex, the y value for the vertex, because you just plug in the x value into this, the x value that you get from minus b over 2a, and that will give you it. Okay? So in this case, let's look at this. A is equal to 1, B is equal to negative 4, C is equal to 3. So the x value at the vertex is equal to minus b over 2a. So what is b? B is negative 4. There it is. So what is minus b? It's going to be positive 4. What is a? A is 1. So what is 2a? 2 times 1 is 2. So the x value is 4 divided by 2 is 2. So now that we know the x value at the vertex, we need to now find the corresponding y value at the vertex. In other words, when x is 2, what is the value of y? Well, what we do now is say, okay, f of 2 is going to be equal to 2 squared, there it is, minus 4 times 2 plus 3. So that's going to be equal to 4 minus 8 plus 3. And that seems to me to be negative 1. So the vertex is the point 2, negative 1. So the vertex, like the parent function will be 0, 0. So it means that the vertex went 2 to the right and 1 down. 2 to the right and 1 down. Okay? So what is the axis of symmetry? Axis of symmetry is x equal to 2. that vertical line passing through the value x equal to 2 is your mirror line, is your axis of symmetry. And you're going to have points on the right, points on the left. Okay? So now we have the vertex, we have the axis of symmetry. Let's look if there are any x-intercepts. Where does this graph cross the x-axis? Well, this graph is going to cross the x-axis where y is equal to 0. Let's check it out. If you draw the graph, remember we said the vertex is 2, -1. And it opens upwards. We'll talk about that. It opens upwards. So therefore, it has to cut the x-axis in 2 spots because the vertex is below the x-axis. So we need to get these 2 points. But don't you see that if it's on the x-axis, y is 0 along the x-axis. Similarly, on the y-axis, x is 0. Everywhere on this axis here, the y-axis. This is y and this is x. Everywhere on the y-axis, x is 0. Everywhere on the x-axis, y is 0. So I can just take this to find the x-intercepts. We put 0 where we see y and then solve that equation to get the x values or the zeros or the x-intercepts or the roots or the solutions of that equation. See, I use 4 different synonymous terms, okay? The intercepts, the x-intercepts, the roots, the zeros, and the solutions, okay? Good, so let's go to work. Let's make it happen. So I'm gonna put right here, the vertex we determined was 2, -1. Is the vertex. And the axis of symmetry is x equal to 2. So let's see if we could work on solving to get the x-intercepts. Okay, so x squared minus 4x plus 3 equal to 0. In a previous Learning Together session, and I'm so glad we did all of that work before, because we keep building on what we have already done. We're not reteaching those things. They're already done. So you could actually search using my name, Desmond Dunkley. And of course, you see the Brosis Foundation. If you search, you'll see the session that had to do with quadratic equations, solving quadratic equations. Okay? You'll be able to see how to solve that. And in this case, we're lucky we can actually solve by factoring. We also learn how to solve by using the quadratic formula. We also learn how to solve by completing the square. Okay? So here we go. This is x minus 3 times x minus 1. If we expanded this properly, it will give us this. So from this, using the zero product property, again, this is one of the concepts we covered when we studied factoring and solving equations of higher degree. Okay, so from this, we end up with x is equal to 3 or x is equal to 1. So now we know that it cuts the parabola cuts the x-axis in 2 spots. +1, +3. And remember, 2 is smack in the middle. 1 to the left, 1 to the right. So now we have 3 points. So we need to get, or we'll try to get 2 more points. Well, 3, we try to get 4 more points. 2 on the left, 2 on the right. We try to get 2 on the left, and then we just duplicate to the right. So here we go. Next, we're going to try and look at the y-intercept. For the y-intercept, x is 0 because it cuts the y-axis, and along the y-axis, every point along the y-axis has an x value of 0. Any point you take is going to be 0 and a number, 0 and a number. And of course, right at the origin, right at the center of the axes where the two axes intersect, the x and the y would be the point 0, 0, which we call the origin. So what is the y-intercept? Well, x is 0. So looking at the formula, the y value is going to be equal to 0 squared minus 4 times 0 plus 3. So that's going to be equal to positive 3. So the point 0, 3 is one of your points. And on the other side of your axis of symmetry will be the point 4, 3. This point corresponds to that point. It's the mirror image of this point. With the mirror, the axis of symmetry smack in the middle, x is equal to 2. So 0 is 2 from 2. So we have to go 2 to the right, and then of course go up 3. And that will be the corresponding point for the y-intercept. So now we have 2, 3, 0, 1, 0. So that's 4, 5. So we could just choose one more point and then call it a day. So if we chose when x is -1, what will be the value of y? Well, f of -1 is going to be equal to -1 squared minus 4 times -1 plus 3. What is that equal to? This is 1 plus 4 is 5 plus 3 is 8. So therefore we have this point -1, 8. And what is the corresponding point on the other side of the axis of symmetry? Well, -1 is 3 units from the axis of symmetry. So therefore, for the corresponding point, you have to go 3 units to the right. So 2 plus 3 gives me 5. So the other point is going to be 5, positive 8. So now we have 7 points. That's sufficient. And now we're in a position to sketch our graph. Okay, so I have all this information, but I need to make space. So I'm going to erase some of this. So we have -1, 8, which corresponds to 5, 8. And over here we have 0, 3, corresponds to 4, 3. And then of course we have these points here. 1, 0, corresponds to 3, 0. So let's go. So we know that 2 this is 2, 3, 4, 5. 1, 0, -1. How far did we go? We go as far as 8. Let's go like this. Okay, so we said that the vertex is 2, -1. 2, -1 is a vertex. So we know that our axis of symmetry Okay, so that's our first point right here. And then we're going to have -1, 8. -1, 8, and 5, 8. And then we have 0, 3, 0, 3, and 4, 3. Then we have 1, 0, and 3, 0. If you see the points, come this way and go this way. So here we go. There it is. Okay? So the vertex is 2, -1, and we have the other 3 points, which give you the symmetry, and then we just connect the points, and that's your sketch. This is the first one we have done together. We're going to do another one to reinforce the steps, and you should be able to have all the steps clear now that we're going to go through them the second time. Okay, so first I gave you the theory. Now we have actually done an example, and I'm going to do a second example to reinforce the concept. So stay with me while I erase and come up with a second question. Okay, before I do that, I just want to point out that the general form is y equal to ax squared plus bx plus c. If a is positive, that is, it's greater than 0, if the lead coefficient is greater than 0, our graph opens upwards. So it opens up. Think of up as positive. If A is positive, the graph opens up. If A is less than 0, that is, A is negative, the graph opens down. So we have the reverse, so it becomes an inverted U. Okay? So in this case, you will end up with a minimum. So if A is positive, your graph opens upward, your vertex is at the bottom, and therefore you have a minimum value for your function. If your graph is, if the lead coefficient is negative, your graph negative, think of it opens downwards. It opens downwards. So now you end up with, your graph has a maximum. And that makes sense that you're starting from where it was at the highest, and because it's negative, it goes down. If it's positive, it starts at your lowest point, and all you know is the next thing is brighter, it goes up, 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 up. Okay? So it's important for you to have that differentiation. So when you see your lead coefficient is negative, you know that your graph is going to open downwards. When you see your lead coefficient is positive, you know it's going to open upwards. Okay, so let's see if we could find an example and make it work. Okay. Let's find an example. Okay. Let's try this one. Y equal to negative 2x squared plus 8x plus 10. So the graph we had before was y equal to x squared. Was it x squared, I think? Let me double check. Y equal to x squared minus 4x plus 3. So it was positive x squared. This one now is negative 2x squared. So that's different. Okay? And of course, we could rewrite this as f of x equal to negative 2x squared plus 8x plus 10. Okay? So first thing is vertex. For the x value is minus p over 2a. That's the definition of the x value at the vertex. It's minus b over 2a. So what do we have here? It's going to be equal to minus 8 over 2 times, what is a? Negative 2. So in this case, it's going to be negative 8 divided by negative 4, and we get positive 2. And then what we can do now is find f of 2 is going to be equal to negative 2 times 2 squared plus 8 times 2 plus 10. Whoa. So this is not pretty. Let me double check quickly. So this is going to give me a big number. Okay. So this is equal to 2 squared is 4, negative 2 times 4 is negative 8, plus 16 plus 10. So that gives me 18. Wow, that's a big number, 18. So we're gonna have to work with that, okay? So our vertex is the point 2 vertex, 2, 18. And of course, the axis of symmetry x equal to 2. Okay, so now we need to find a couple points, a couple of additional points so we can sketch our graph. So let's find the x-intercept. So x-intercept at the x-intercept, y is 0. So I can write negative 2x squared plus 8x plus 10 is equal to 0, and try and solve that. Well, the first thing I'll do is divide both sides by negative 2. I end up with x squared minus 4x minus 5 equal to 0. When I divide by negative 2, I get x squared, negative 4x minus 5. And of course, I see here that I can actually factorize. So all those skills we did in previous learning together sessions are coming into play. And what do we have here? Two numbers multiplied to give us negative 5 and add to give us negative 4. So it has to be plus 1 and negative 5. Let's check. 1 times negative 5, negative 5. 1 plus negative 5 is negative 4. So what are the intercepts? The intercepts are x equal to negative 1 or x equal to 5. 5 from here, negative 1 from here. So what are the points we have here? We have negative 1, 0, and also 5. So what we have here, we have the vertex is 218 above the x-axis, negative 1, 0, and 5, 0. And now let's see if we can find the y-intercept. The y-intercept. The y-intercept for the y-intercept, we know that x has to be 0. At where it cuts the y-axis, x has to be 0. So we know y is going to be equal to -2 times 0 squared plus 8 times 0 plus 10. So that gives me 10. So the y-intercept is 0, 10. And check this out. Our axis of symmetry is 2. So 0, 10, okay? So when you go to 2 is a mirror. So we have to go 2 more, so it's 4, 10. So we have 0, 10, as well as 4, 10. Okay, so now we have 5 points. Truthfully, we have enough points that can give us what we're looking for. We really don't need to find more. Let's see if we can sketch the graph now. So the most of the graph is above, the most of what we have here is above the x-axis. So we don't need a lot of space down here. So we can go ahead and draw the so this is our x-axis, this is our y-axis, this is the point 0, 0. And it's a bit, what we have is 2, and this is, let's call this 20, call this 10. Okay, so here we go. 218, so that is 20, this will be 15, so 18 will be about here. So this is our vertex. That's our vertex. And our graph, notice it's negative, so it's going to open downwards. Negative is down. So your U opens downwards as compared to opening up. Up is positive, okay? So here we go. So that's our vertex. And our x-intercepts are -1, so this will be 2, -2, -2, so this is -1, this is 1, this will be 4, so it's 3, this will be 4. Okay, let's rock and roll. So you have -1, 0 is one of your intercepts, and the other one is 4. Sorry, 5, we need to go to 5. 5, 0. So check it out. Here, 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 here. And then we have 2 more points. 0, 10. The next one is 4, 10. Okay. So this is a little bit off, just a little bit off. This should be negative. Okay. Good. So here we go. Okay. Okay, so the graph opens downwards, and the vertex is here, which is a maximum. Okay, and then that over the graph of -2x squared plus 8x plus 10. All right, so let's summarize. So a parabola is a symmetrical shape. Okay, can be in the form of a U that's open upwards, open downward, and also you're going to find out that it can also open to the left or open to the right. We'll discuss that at a later time. we discover that a parabola has turning points. So when drawn like this, you have the maximum whenever you have a negative lead coefficient, you have a maximum. If you have a positive lead coefficient, you have a minimum where it opens up. So if this is negative, it opens down. If it is positive, it opens up. You know that there's what is called an axis of symmetry. The turning point is called the axis, not the axis, sorry, it's called the vertex. The turning point is called the vertex. And the line that passes through the vertex, the vertical line that passes through the vertex is the axis of symmetry. So the parabola is symmetrical about that axis. So you have equal amount of points on the left, equal amount of points on the right. Okay, what else? And in order to graph the parabola, you don't need, or to sketch the parabola, you don't need a lot of points. Basically, because it's symmetrical, you need to find 3 or 4 points on the left, and then you have the corresponding points on the right. So just by finding the points on the left, you're able to match across to the right because they have the same y values. And then just connect, and there it is. That's your parabola, okay? One last thing, we discovered that your parent function is y equal to x squared. If we add a number here, then it causes your graph to go up. If you subtract with a negative number here, it pulls the graph down. All the points come down by the amount of that number. However, if we put a number inside the parentheses, like for example 3, something like that, then this number causes your graph, your vertex, all the points on your parabola to shift to the right. Negative causes you to go to the right. And if it was positive, it caused you to go to the left. So therefore, if you see something like this, y equal to x plus 2 squared minus 5, and I ask you, where is the vertex? You'll be able to tell me that the vertex is going to be -2, -5. So it goes 2 to the left and 5 down. So -2, -5 is your vertex for this graph. Okay, we'll talk about that some more in our next session. So, welcome to Graphing and Analyzing Parabolas, Part A. This is our first session. Next time we meet, we'll cover another portion. We might have 2 more sessions, but at least 1 more, but possibly 2. Okay, thank you for joining us. Hope this was challenging, different, but also inviting. On behalf of the Rusea's Brosis Foundation, we thank you for joining us and spending this time with us. Please pass the word along. Invite your friends, your neighbors, your family to go visit the Rusea's Brosis Foundation Learning Together sessions. We have sessions in both mathematics and also in English. Our English sessions are held on Wednesdays, and we have them recorded so that you can access them over and over and over at your leisure. Okay? So, thank you so much for joining us, and do enjoy the rest of your day. Thank you.